Hi, this is Module 2, Lesson 1, Connecting the Dots, Piggies and Pools. This lesson, we are having a culmination of everything we did in Module 1, and we're adding in the continuous and discrete ideas when it comes to graphs. So to start with, let's look at number 1. My little sister Savannah is 3 years old. She has a piggy bank that she wants to fill. She started with 5 pennies. And each day when I come home from school, she is excited when I give her 3 pennies that are left over from my lunch money. We need to make a table, a graph, and an equation to create a mathematical model for the number of pennies in the piggy bank on day n. So let's start out with a table. So when I make my table, I know I am starting with, not a whole lot of space here. I'm going to erase some of those. So when I make my table, I'm going to make it over here. Since I'm starting with 5 pennies, let's put it over here, day, pennies. Then I get 3 pennies each day. So the first day, she'll get 3 more pennies, which is 8. Second day, 3 more pennies, which is 11. So here's the start of my graph. I'm actually going to do my graph on the Jamboard so that it's a little bit easier to read. But let's go ahead and do my equation next. So if you want to do the recursive, f of 0 equals 5, f of n equals f of n minus 1. And what am I doing each time? I'm adding 3 pennies each day. So that makes my explicit equation, f of n equals starting with 5, and then I'm adding 3 repeatedly. And because I've started with my 0 and my 5, I leave it as just n. So there's my equation. Now let's go over to our Jamboard and let's make a graph of these. So to start with, let's do my table again. So my days, my pennies, keep in mind this is my x and my y. I usually want to make a point to do those, x on the left, y on the right, or x at the top, y at the bottom. Day 0 is 5, day 1 was 8, day 2 was 11, and let's go one more. Day 3 was plus 3, 14. So when I make my graph, I've got my grids on here. I'm going to do my best to follow the lines. And since these are all positive numbers, I'm not going to have negative days and I'm not going to have negative pennies. I'm only going to do the first quadrant. And these numbers are pretty close together for me to try to do this on my computer. So I'm going to label my axes. So I'm going to go every other. So this is 1, 2, 3, we'll just go up to 5. 5 days. And looking at what I've got over here, I'm going from basically 5 to about 14, a little bit higher as I'm getting into these. So I'm actually just going to mark every 2. But I've got the lines in between there, so if I do have an odd number, I can fill them in. 6, 8, it's not writing well, 10, 12, 14, 16, 18. And so now when I go to plot this, I'm going to do it in green. So day 0 is 5, so that's right in between my 4 and 6. Day 1 is 8, that's on the grids. Day 2 is 11. Day 3 is 14. 14 plus 3 would be 17, and then I'm off my chart. So now the next thing I need to figure out, is this going to be continuous or discrete? Well, continuous means I'm going to connect those dots because I could have half of a day and get pennies, or I could have, say, 7 pennies or 10 pennies. Discrete's going to say, no, all you can have are once a day, and you can only have these numbers of pennies in the piggy bank. So in this case, it would be discrete, and I would leave these as dots, and I would not connect them because I cannot have anything between 5 and 8 or 8 and 11, and they only put them in once a day. So I can't come in at noon, come home for lunch, put in some pennies in between. So that is my graph for number 1. So let's go back to here and look at number 2. So number 2, our family has a small pool for relaxing in the summer. And scroll this up a little. That holds 1,500 gallons of water. I decided to fill the pool for the summer. When I had 5 gallons of water in the pool, I decided that I didn't want to stand outside and watch the pool fill. So I had to figure out how long it would take so I could leave and then come back and turn off the water at the right time. I checked the flow on the hose and found that it was filling the pool at a rate of 2 gallons every minute. Use a table, graph, and equations, we need all 3 again, to create a mathematical model for the number of gallons of water in the pool at t minutes. So I'm filling up the pool, so the pool is going to get more. It's going to fill up. So let's make my table. I'm going to make that a little bit lower down here. So my minutes and my amount of water. So at 0 minutes, I'm starting with 5 gallons of water. At 1 minute, I've got 2 gallons more, so that puts me at 7. 2 minutes, 2 gallons more, 9. And we'll do one more down here. I think I can fit it. 3 and 11. So I'm going to jump straight to my explicit equation for this one. So with my explicit, it's a plus 2 each time because it's 2 gallons every minute. So I'm going to f of n equals, I'm starting with 5, and I'm adding 2 gallons every minute. Once again, because I'm starting with 0, if I substitute a 0 in for n, 2 times 0 is 0 plus 5, I get my answer of 5. So I can leave it just like that. Let's go make our graph. So I'm going to go to another page here, clear that up, and put some grids on there. So my table, really quick, was minutes and amounts, again, my x and my y. 0 was 5, 1 was 7, 2, 9, 3, 11. Let's go one more. 4 plus 2 is 13. So when I go to make my graph, again, I'm going to follow my grids, do my best on that. This is minutes. This is amount of water. And so I'll do what I did last time. 3, 4, 5. So I don't actually have to label every single one of them, but as long as I label some of them in there so that I can see, oh, I'm counting by ones, then that's okay. Here again, I'm going to do 2, 4, 6, 8, 10, 12, 14, 16. Okay, so I've labeled so I know I'm counting by ones on my x-axis. So these guys are ones. Each line counts for 1. Here I've shown that each line counts for 2. So as long as you have some labels, you're good on there. So let's go and graph this. 0 this time is 5, so 2, 4, 5. That was the same as last time. 1, though, is 7, right in the middle there. 2, 1, 2 is 9. 3 is 11. And if you notice too, my slope is up 2 over 2, up 2 over 2, up 2 over 2. So I could notice that, oh, I can just kind of follow that pattern as I'm going. All right, now we got to determine, are we continuous or discrete? Well, can I have an amount in between 5 and 7? Could there be 6 gallons in the pool? Yes, the hose is running. It's not like I'm dumping a bucket with 2 gallons every minute. The hose is continuously running. Could I check how much water is in there at 30 seconds? Yes, I could. So in this case, this would be a connected line, and it would be continuous because I can find all those pieces in between. Let's go back and look at the next problem. 3, I'm more sophisticated than my little sister, so I save my money in a bank account that pays me 3% interest on the money in the account at the end of the month. If I take the money out before the end of the month, I don't earn any interest for the month, so it's only once a month that they put in the money. I started the account with $50 that I got for my birthday. Again, a table, graph, an equation to figure out kind of what he is at whatever month we choose. So we have months and we have money. How much dollars? So if he starts with $50, that's my 0. 3%. How do I figure out 3%? Well, if we want to do this in one shot, how much is he getting each month? He's not only getting the 3%, but he's also getting the 100% of his original amount. So that gives us a total of 103%. So I want to multiply by 103%, which is 1.03. So 50 times 1.03 is $51.50. $51.50. And if I want to know what he has after 2 months, we're going to times by 1.03 again. And now I'm at 53 point, now it's 045. So round up, 53.05. We'll do one more here. Times 1.03 is 54.64. I'm running into my next problem. All right, so let's make our equation. I'm going to stick with the explicit because that's the one that's, if we want to know in months, we have to have explicit. That way we can plug in our number. So f of n equals my starting amount, $50. And since it's a percentage and we're multiplying, I'm going to multiply by 1.03 repeatedly. Repeated multiplication is an exponent. And again, I'm starting with a 0. So if I put in a 0 for here, 1.03 to the 0 power is 1. 1 times 50 is 50. So I know I can leave it like that. All right, let's go graph this one. Next page. We have our table that I don't remember all of my numbers for. Let's see if we can do this. We have months and we have money. 0 is 50. 1 was 51.50. 2, I'm going to have to do this one again. 51.5 times 1.03, 53.05. 3 was 54.64. I'll do one more here. 4 is 56.28. That gives you a chance to try solving that as well. So we're going to make our graph. Again, these are all still positive numbers. We're not going to go into negative dollars. He's not owing anybody money. We're not going back in days. So this is months. This is money. 1, 2, 3, 4, 5. I can always add more since I have room. Now here I'm going from 50 to 56. So I actually want to count by ones, and I'm going to do a little zigzag there. That shows that I'm not going to do everything from 0 to 50 because it's just going to be put my graph way up at the top here, and I don't need to waste all this space down below. So let me erase those. So I'm going to use this little zigzag, and this basically means the bottom part is not going to be even, but once I'm above this zigzag, it will be. So I'm going to go 50, and then I'm going to skip and go 51 so that I have the 50 cents brought up in there. 53, 54, 55, 56, 57. So again, I put enough numbers in there that I can see what I'm counting by. The zigzag means I'm jumping from 0 to 50, but now it's going to be consistent above 50. So when I go to graph this, we have 0 is at 50, 1 is at 51.50. So now see I've got that spot where I can go in between. 2 is at 53.05, so it's just tiny bit above 53. 3 is 54.64, so that's about 54 and a half, just a little bit above that. And 4 is 56.28, so that's a little below 56.50. Okay, so with my graph, you can't tell it quite as well at this point because we haven't gone very far, but we are explicit. There should be a bit of a curve here. If you notice between these guys, it's not entirely even because that's $1.50 and this is more than $1.50. And then this is bigger yet than $1.50. It's just slowly getting bigger, but with only 4 dots, you can't tell quite as much where that is. So again, continuous or discrete. Do I need to connect this line or not? Well, it said if you took the money out before the end of the month, so that'd be at the half month, you don't get your interest. So that means I can't have $51 even. I can't have $50.12. There's no in-betweens. I can only take it out at the end of the month. So these would have to be discrete and kept just as dots. Only dots not connected. All right, one more graph. Over here, we have at the end of summer, number 4, I decide to drain the 1,500-gallon swimming pool. I notice that it drains faster when there's more water in the pool. That's interesting to me, so I decided to measure that rate at which it drains. I found that 3% was draining out of the pool every minute. So we know we start with, let's see, we have minute. So we want minutes and amount because we want to model the gallons of water in the pool at t minutes. So at 0, we start at 1,500 gallons. At 1 minute, it's 3% less. Well, what's a 1,500 as our percent? 100. It's at 100% capacity right now. If we lose 3%, we're taking away 3%, which means we now have 97% in our pool. So if I take 1,500 times 0.97, I'm going to get 1,455. So this is a times 97%. Write these down so I have them for next time when we get to the next page. So now if I go to 2, I'm going to times by 97% again, and I get 1,411.35. So 1,411.35. Let's go one more number. 3 times 0.97 is 1,369. Pretty even. The decimal's 0.009, so we'll just leave it at 1369. And so each time I'm taking it times a 0.97 because I only have 97% of the water left in the pool. All right, let's do our explicit equation. F of n equals, what did I start with? 1,500. And I'm multiplying, I'm going to do a 0.97 over and over. Double check. Start with a 0. If I put in a 0, I do get 1,500. So I don't need a -1. One more graph. Let's take a look at this one. So this guy, we've got our table here, minutes and amount of water. 0 is 1,500. 1 was 1455. 2 was 1411.35. 3, 1369. I'm actually going to do one more because I like to have at least 4 to 5 plots on here. And this one is 1327.9, so let's do a 1328. All right, making our graph. Follow my grid lines. I have minutes and amount of water. All right, I'm going to still do my 1, 2, 3, 4, 5. And so here I'm going from 1,500 to 1,300. And we are going to go kind of down, but it's really only about 200 difference in here. So again, I think I'm going to do my zigzag for the moment because we only have 4 points. We're not going to get down to 0. I'm going to start up here and just do, let's do 150. So let's start with 1,300 and 1,350, 1,400, 1,450, 1,500, 1,550, 1,600. So you could actually even probably break it down more if you would, if you wanted, and do maybe 25s even. Well, I guess each line's a 25 if you want to be a little bit more accurate and see the curve better. So let's just plot what we have. We started 1,500 and we're going to 1,455. So it's right by the 50, 1,450. Then it's 1,411, which is just barely above this one. And then we're at 1,369, which is kind of right in here. And then we're at 1,328, which is really right about here. So again, you can kind of see, not the best with only these 4 points, but there should be starting a curve on this. And they're not even distances apart, as you can tell. So that's a note that we don't have a slope, a common slope, but it's more of a ratio. But it's starting to curve, and as we keep going, it'll keep going. So let's see, continuous or discrete? Continuous or discrete? Well, if I'm filling the pool, or draining the pool, I guess this time, if I'm draining the pool, it's going down. Could I check it at 30 seconds? Yes, I could. It's all draining. It's not like I'm stopping the plug and then instantly 3% is out, it's continuously dropping from 0 to 1, 1 to 2, 2 to 3. I could pick any numbers in between. At some point, it will be 1475. At some point, it will be 1400. So this one would actually be connected as you're going. So that would mean it's continuous. So it's a continuous flow. So this is the big piece in this lesson is, do we connect the dots or not? Last time we were, because we did every time. We didn't really think about it. This time we need to make a focus on that. So comparing problems 1 and 3, what similarities do we see? Well, both of those involved money. They were the piggy bank ones. They were both money, and they both were not connected. They earned money at the end of the month. They earned money at the end of the day. So both were discrete. Here's where I want to see your vocab. Both are discrete. Differences. Number 1 was linear. Should have been a straight line. Number 3 was geometric. Okay, let's compare 1 and 2. So 1 and 2 were the piggy bank and filling the pool. Well, similarities, they were both linear. They both made straight lines. It was a constant rate. It was +3 each day or +2 gallons every minute. The differences, though, number 1 was discrete, and number 2 was continuous. So when they're talking about comparing them, that's really what they're talking about. Let's talk about discrete. Let's talk about what the shape of their graph is. Another similarity was they both started at 5. One started with 5 pennies, one started with 5. 3 and 4. Okay, so 3 and 4 were about the interest in the bank and also the draining of the pool. So 3 and 4 were both geometric. Percentage is a ratio, and both of them are and 3%. One was earning 3%, one was draining 3%. So differences, one was going up, one was going down. So 3 was going up, and it was discrete. Number 4 was going down, and it was continuous. So that's the big piece to this unit, or this lesson, was can you do all those pieces we've talked about last module? And then let's be pickier on those graphs and say, are they going to be discrete? Are they going to be continuous? Thanks for joining.